Hello, everybody. Welcome to October 2025 of MergePHP. We've got Glenn here, who's going to be presenting a little bit, but first let's just talk about MergePHP for a little bit. Ian, you're sharing. Let's go ahead and go to the next slide there. So MergePHP, as you all know, is a collection of a bunch of user groups that have joined together to meet every month and talk about a PHP-related topic. These are the meetups that have joined us so far. If you are a meetup organizer, we'd love to have you too, so get in contact with us and you can join us here. Let's go to the next slide there. So every month at our meetups, we raffle off a one-year license for any JetBrains product. That can be PHP Storm, or if you do a lot of other languages, you can use one of their other wonderful IDEs. And I believe that also works for the All Products Pack. So the first person that emails chris@atlantaphp.org is going to be the winner of that license for this month. We always like to remind you that PHP does not last forever. So if you're on 8.1, please do plan on getting up to the next 8.2 or beyond. I can tell you that the versions of 8x are definitely very, very easy to go from one to the other. It's not quite as bad as 7 to 8 was, and definitely not nearly as bad as 5 to 7 was. And coming up later this year, we do have the scheduled release of PHP 8.5 in late November. All right. And if you're here, we know you like continuous learning. So if you want to do even more continuous learning, either in person or online, there's a plethora of conferences happening both in the US and throughout the world, both online and in person. And of special note, we actually happen to have one of the organizers for Longhorn PHP here, and Ian's going to tell us a little bit about that that's coming up in 2 weeks.
Once I get off mute. And fiddle with the where people are on video because, well, Tim, I'll let you do that while I talk. Thursday, October 23rd is the first day of Longhorn PHP, and we have a special MergePHP or Austin PHP live meetup on site there at the venue for Longhorn PHP. So if you are in the area, whether you are attending the conference or not, obviously it'd be lovely if you attended, given that we've got a whole ton of content Thursday for tutorials, and then Friday for main sessions, and likewise Saturday. But even if you don't, show up 6 p.m. Central, either online streamed via the MergePHP channel or in person here in Austin, and we're going to do lightning talks. I'm going to paste a link to a form to sign up for lightning talks in the YouTube chat as soon as I hop off of here. And whether or not you actually submit that form, it'd be nice if you submitted, but either way, come prepared to with a lightning talk, or just tune into the stream or show up live, and we're gonna have a good time. In addition, if you haven't gotten a ticket yet and can make it down here in the 2 weeks or so before when the conference happens, again, that's Thursday through Saturday, October 23rd to the 25th. We have some promo codes on screen. These are valid today. So as you're seeing this, you have about 6 more hours and to grab your ticket, whether that is an in-person ticket, either for the main conference days, Friday and Saturday, or tutorial days, Thursday, Friday, and Saturday total. Or if you attend online, that is Friday and Saturday, $25 off. You can go to longhornphp.com, use the ticket purchase thing there, throw in the promo code, and you'll get actually the same pricing we had for early bird. And that is valid until the end of today. And once I hand it over to Tim, I will throw a link in the chat to sign up for the lightning talks for Merge, again, whether you attend the conference with a paid ticket or not.
So yes, everyone, please, if you have a topic that is PHP related that you want to share with the audience, it's just a lightning talk, so 10 to 15 minutes in length. It does not need to be the most revolutionary topic or anything that's like had a lot of pizzazz, just something that you know about that you think other people might be interested in. Please submit a lightning talk and we'd love to have you. MergePHP is also on all the socials. We also have a channel in the PHP community Discord if you want to come in there, hang out with us, or suggest some topics, or maybe run by an idea for an upcoming talk. You can find us in there. Next. Next month, Ian Littman's going to be back again talking about PHP 8.5G, or unless maybe we can get one of the potential release managers to talk about it, because, hey, who wouldn't want to hear from one of the release managers about all the new features of the language that they're releasing? So if Ian can get one of those people, he will, and if not, you'll get to hear him again. If you have a talk idea, or you just have a topic that you want us to present about and you want us to find a speaker, reach out to us at mphp.io/speakers, fill out the form, and we'll do our best to get back to you. All right, so we're going to get into this month's presentation, and this month we're going to hear from Glenn Nagels, who's going to be talking about rolling your own graph-driven MCP server with Neo4j. So Glenn, why don't you take it away?
All right, thanks, Tim. So yeah, indeed, my name is Glenn. Maybe before I start, I'll start sharing my screen. Let me share my Google slide deck. There you go. Let's see, is this visible? It's looking like it's visible. So unless somebody stops me, I'll keep talking. So yeah, indeed, today I'll be talking about rolling your own graph-driven MCP server. It's a little bit of a mix match of a lot of technologies. It's an interesting talk, I want to say. There is MCP that's going to be in here, how to build it with PHP, and we're going to talk a little bit about Neo4j. To tell you a little bit about my technical background, I started my career being the developer of the Neo4j driver, which is how I got. Neo4j is a graph database, for those that don't know, which is how I got in touch with these technologies. These databases tend to be very forward-looking. They have a lot of AI applications, data science attached to it. And so even though I'm a die-hard developer, not like a data scientist, I feel like MCP is this place where you can interact with AIs while still being more like a developer. And just a little bit about me before we talk. So I have a small IT consulting company. We focus mainly on PHP, Docker, and we're based in Mumbai. So when I accepted to this talk, I forgot to take into account that I would be in Mumbai. So it is 4:40 a.m. in the morning today. So you'll have to forgive me if I'm a little bit low energy or something like that. But yeah, here is if you want to reach out to me, this is how you can. And yeah, I'm excited to get started with this. So as always, there's going to be a little bit of a game plan. At first, I just want to talk on a high level what MCP really is. I feel when I was doing some research for this topic, I found it difficult to find a clear starting point for developers, how this all works. I feel like since it's moving so fast, it's difficult to get a clear overview. Then I'll give some specific examples of how to develop it using PHP, of course. Then because it's going to be graph powered, even though there are a lot of graph technologies, I'll be using Neo4j. Just very 5 minutes explaining what Neo4j is, or the graph technologies is, and why it's a good fit for MCP. And then I thought it'd be fun to have just a demonstration because, hello fellow runner, thanks Mark. Anyway, so yeah, then I'd like to do a graph-powered MCP demo because I feel, especially with AI, sometimes the best way to show the way it works is to actually show it instead of staying in the land of theory. because it's very real right now, and you could gain some amazing quality of life boosts as a developer employing these technologies. So let's get on it. MCP, the high level. I think more importantly, MCP, all of these technologies, they exist to solve a problem, right? Or to solve many problems. And I think there's three core problems that traditional agentic LLMs have. One of them is the problem of data silos. So as we all know, like LLMs are trained on data. They don't have any new data, so there are a lot of ways of augmenting that with real life data that is relevant to your business, to your tech stack, to whatever it is. There are many tools for that. MCP tries to be one of those tools. There's also, of course, a problem of standardization. Every AI platform basically is trying to have their own integration, and at some point, as always, somebody comes along and says, we have a standard. For all I know, there are now 5 different standards, but the one that right now is the most promising is MCP. And then there are a lot of security concerns. I think the AI is famous for what's it called again? The paperclip problem, right? If you ask AI to build a paperclip, it'll do everything in its power to build paperclips. Very similar things are happening with agentic AI. If you tell it, for example, make this test go green, it may decide if you let it completely loose that instead of fixing the code, it'll just fix the state of the database or things like that. That's a security concern. You want to be able to limit that. There's many different examples of this. MCP tries to solve that problem as well. So yeah, this is it, the technology, Model Context Protocol. I have a huge logo of Anthropic here, not because I'm affiliated with Anthropic in any way, shape, or form, but I feel when it comes to these standards, it's relevant to know like which companies are driving this. Mainly it's Anthropic right now. They're the ones who started this all. And I feel when it comes to MCP, I want to look at it, explaining it as kind of like an onion, peeling away the layers. The outer layer is just being like, as a vague concept, how is MCP supposed to interact with other things, or with what is it supposed to interact? And really, it's supposed to interact with anything. The whole concept is that something like an LLM is able to talk to MCP, and then MCP, that protocol, will arrange it so can go integrate into your chat system. It'll be able to access your data. It'll be able to access Git, anything you can think of really. And the talk is mainly focused on how you build the MCP server. So really, we are the ones who can integrate whatever technology or whatever tools we want to enable the AI to use. We can once you know how to build an MCP server. So MCP is a very central technology, and within this standard, there's basically 3 big actors. There is the LLM itself, which you can think of as the brain, which will act on the client, which you can think of as the connector. It's a pretty complicated piece of technology that basically receives structured requests from the LLM and then sends them to the appropriate server. And the server, which is the part that we're going to be talking about the most, you can think of as kind of like the body. It's the thing that performs the real actions and retrieves the real data for the LLM. So just some technical details. The standard has a well-defined format. It's built on top of JSON RPC or JSON remote procedural calls. It has 2 main transport layers that it supports. There is standard I/O and there is HTTP. It's very clearly documented that they prefer standard I/O, which I think is an interesting thing because usually client-server, oftentimes you think of it as them being on separate machines over a network, but they really try to push for a way that MCP works best if the client and the server are on the same machine, because you can only do that if, Studio only allows this type of connectivity over the same machine. It helps with having it on the same machine, helps with security, reduces latency, and It also makes packaging the server more easily. It doesn't need to support full HTTP, WebSockets, whatever it is. It can just hook into the I/O from the operating system. And you can see like a clear data layer here. How it's supposed to go. The LLM talks to the clients. This part tends to be proprietary. And then the client talks to the server, which is a well-defined JSON RPC, usually over standard I/O. And then the MCP server, which is what us developers are supposed to do. We then have our own system to talk to whatever we wanted to talk to. In our example, it'll be a graph database. So another part that I feel like is essential to understand is just like, okay, how does the LLM know how to interact with my server? Like, how does it know what is possible? And all of that basically gets communicated in the initialization phase. So this is a moment where the client basically goes to the server and is going to ask, what are your capabilities? What is available? And the server will then respond saying, for example, well, you can write queries, you can run queries, you can look at the database schema, for example. And then the client, of course, will communicate that to the LLM, and then the session will start. So, for example, if you're using AI or LLMs a lot, it's supposed to be short-lived, like somebody opening a chat window, you do a few things, your context window fills up, and then there is a graceful shutdown that happens afterwards. So this, I think, if you want to get started building your own MCP and you want to do it with the bare minimum knowledge, I would say that the only two things you really need to know as a server developer and you're using SDKs is you need to know what a tool is and you need to know what a resource is. The primitives, the three primitives that MCP provides are really just the three types of messages that can be sent to your machine. So the first primitive is a tool. This is basically the most straightforward one. Is basically the giving the LLM a tool to act. So it could be, hey, you can run a query on my server, or you can send an email on my server. It'll have some predefined parameters, who you're going to send the email to, what the query is going to be like. It could be the craziest thing. It could be you could hook it into a coffee machine and your tool could be make a coffee, all of this is possible. Then the other part is the resource part. This is more the static part, context, that is going to be very helpful for the LLM to know what the environment looks like. And in a database, that's very clear. Something like that could be the schema, so it knows what types of queries it can run, or could be like details about your organization, who's working for who, I don't know. Like this could be whatever is important for your server could be there. And then there is the most confusing part, and it's also the least supported part, which is prompts. And prompts, I feel like, is one of those things, I don't know if it's going to last, if it's going to stand the test of time. But that is basically a way for the server to say, there are complicated operations that can be done, and you just define a predefined workflow that the user can invoke. For example, travel booking, right? So travel booking could have a start date, an end date, a location, a transportation mode, whatever you can think of. So you're basically communicating that to the client and to the LLM. Hey, this whole system can support this, and then the LLM can work out like which tools it has to run based on those parameters. And you can see that in your client. Usually it's implemented if you press the slash symbol in the chat. You'll get a bunch of options, and there usually a small form follows, like what do you want to fill out or what do you want to do. Usually those are prompts. Then there is a part that I know, to be honest, the least about, which is the MCP client. And I think the best way to think of a client is that it is acting a little bit like a web browser as well. It's very difficult to design, just like there are. I mean, building an HTTP server is very simple. Building a browser is very hard. That's why there are millions of servers and not many browsers. Very similar with the clients. It has to manage states, security, UI integrations, LLM interaction loops. And I just feel like this is not something for this talk. This is not something important for the talk, but it's good to know that this is part of the whole standard. And yeah, like if you want to use a client, you probably would be using Claude or Cursor or the OpenMCP client. But all of these are still in many ways experimental, early stage. Things are moving fast. So why would you want to use MCP? I think you need to have a good reason, like unless it's for a hobby and you just want to experiment. If you want to use it in your business, like why would you want to use it? First off, it's again the standardization part. So if you write an MCP server, it's going to integrate in many API platforms. All major players are supporting it right now: Claude, Cursor, VS Codes, ChatGPT, things like that. You're going to be able to enforce certain security rules. Like in your server, you can, for example, disallow write queries. You can make sure that certain things aren't accessible. You can manage your tokens on the server level, things like that. You can add real-time data to your LLM, and it's just very easy to add new tools and resources using MCP. But of course, like any good solution, it comes with its own problems or tales of caution, things that people are figuring out as we're using these tools more and more. I think this is something that is true for everything. A standard doesn't mean that everything is safe. The standard is indeed just a way to say how things operate. But if you have something that allows to run queries, it's still your responsibility to make sure that those queries are safe, that it's not going to run unsafe queries, it's not going to be able to access sensitive data. The protocol doesn't really say anything about that. Then there's also the concept of that context does not mean comprehension. The fact that you are providing valid JSON and RPC formats does not mean that the model actually understands the correct semantics. For example, if I have a run query message or a run query resource, but I give it the name make a teapot, the LLM will not know what to do with it. Like there is still a lot of the design that you as a developer will have to think about for it to be an effective tool. It's also still something, since it's so new, this whole technology has to stand the test of time. If you think about REST, it took like basically a decade to have full-scale adoption. There is no way of knowing if MCP is going to be full-scale adopted right now. It's looking that way, but that's a gamble. And then there is, of course, the context problem, which is something that I've been more and more acutely aware of. If you are having too many MCP servers, you're actually increasing the context window of your chat. It's going to lead to a lot of overload and confusion, and it's going to degrade the performance. There is this sweet spot where having a few MCPs are helping. If you add too many of them, it becomes confusing again. So less is more in many ways. So a good way to bring this all together is just saying that MCP is a open standard that lets AI models securely access live tools and data, and it does so through clients, servers, and it uses a structured, auditable protocol instead of just ad hoc integrations. So this is the part that I think is the most interesting. It's also pretty short because it was actually surprisingly easy. It's like, how do you build your own server, right? First things first, why would you want to build your own, right? Because there are a lot of pre-built ones. For example, with Neo4j, there is a pre-built one available using Go. Why would you want to build your own? I think one of them, which is important to think about in the end, it's easier than you think. Like using the SDKs available to you in PHP with like a minimal implementation, you can get started in like an hour. But then another big part of it, which I think is something that the standards can't provide, which is that you can easily encapsulate core business logic. So you could provide like a tool that provides certain KPIs that you can instruct the LLM, and it's helping you develop or it's helping you ask questions to be like, hey, whatever you do, verify it using this KPI endpoint. So it gets this self-checking loop. There is, of course, a security and compliance part. For example, you could have like more like a weird setup if you're thinking in a development way. Like you could have a Docker setup, you could have a staging setup, a production setup. Like how you could encapsulate all of that logic and the credentials within your own MCP server, something that fits for your team. And then, of course, you just may want to expose your tech to other AIs for like commercial reasons and basically turning it into an AI API. So what are the main tools available right now if you're a PHP developer? There is a PHP SDK. They've been doing a phenomenal job. It's PHP Foundation and the Symfony project coming together. It's the one that we'll be using. There is, of course, a typical Symfony bundle on top of that helps with ease of configuration and integrating all the dependencies, registering the commands for you, things like that. And then there's a Laravel integration, which I don't have experience with, but when I was looking through the websites, it seems like it's been pretty feature-rich. It looks like it's pretty cool. So here is an example of how you would build a tool to show how straightforward it is. We're using the annotations here. So you would, for example, have a function. You'd register it as an MCP tool. And then, of course, using reflection, it'll figure out the arguments, the type of operations, the return type. And your AI would be able to use this now because the SDK will turn this into the predefined schema, and it would turn into something like this. So the AI would be able to read this, or the clients, knowing that these are the type of inputs, these are the type of outputs. And notice like the human readable part, perform a basic arithmetic operation between two numbers. This is the strength of LLMs. Like it's in that way, this documentation matters, right? Again, if the description here would have been, I am a teapot, odds are it wouldn't know what to do with this, the AI. Like all of these contexts matter and semantics. Then, for example, defining a resource is as simple as tagging it as a resource, how to access it, what makes it unique, a description of what the resource will entail and how it will look. Here's, for example, a database schema. And then, of course, it'll translate it to JSON for you. All of this happens in the discovery phase of the capabilities, so you don't have to implement it yourself anymore. And then, of course, setting up your server. I think as PHP devs, we may not have a lot of experience with standard input-output, like it's all HTTP protocol. But I think the code is just very self-explanatory. This is straight from the example codes on the GitHub. And you can build your server, set basic server information, set the discovery. So this is where all your classes and annotations are located. It'll build it based on top of that. And then you have to decide basically what transport to use. In this case, you're using Studio, which is the preferred one. And then you just start listening. And it starts an infinite while loop under the hood, and it'll listen for input and output coming in. It's pretty cool. As usual, I've shown how simple it is, but everything that is simple is always hard to master. There are a lot of pitfalls that happen when you're building your MCP server. A big one is, for example, how to deal with runaway queries. Like LLMs can act a lot like the paperclip problem. I don't know how familiar you guys are with it, but it's basically if you give an AI that is all powerful, just a very simple task as can you make as many paperclips as possible? It may take things way too far, even though it's well-meaning, and discover that there is, and it'll mine the entire planet, scrape other planets, and build just a universe of just paperclips. And we can see that in many ways. Like if you instruct an LLM to do something, sometimes it'll just have complete disregard of server resources, of complexities, of certain triggers. And so when you want to really protect against that, MCP, the server side, is where that responsibility lies. You have to make sure that those queries can't run for too long, that they are rate limited, that they can't ask too many at once, things like that. And there's, of course, the question that it shouldn't be able to touch things that are private. The LLM may want to ask to change confident, like sensitive information. You should protect against that. I think a sensible default is that an LLM shouldn't be allowed to write to your database at all. And then there is Of course, another one, which is that the response that you are sending back also matters, because if you're sending a big response that doesn't have a lot of useful information, it's just going to increase the context window of your AI, of your LLM. It's going to decrease the performance. It's going to make your AI build go bigger, and it may not be useful. So it's huge to consider this when you are providing responses. Like, do you need all this information, things like that. And then if you decide to run it on HTTP, there is all of the typical HTTP rules that apply, course, DNS rebinding, etc. You've got to make sure that you are safe regarding these things. And I think as PHP devs, we should be pretty familiar with these. It shouldn't be a surprise. So servers in brief, I want to say that a server is easy to get started with. It's easy to get started building, but they are very hard to master. While it's very useful, you need to, if you want to make this like production ready, you need to spend a lot of time and consideration into how to design the tools and resources. And you're going to make sure that your backend takes care of all of the pitfalls. And so, yeah, now the question is, how do graphs tie into this, right? First of all, I don't know how many people know about graph databases. So to give you just a complete rundown of what graphs are all about, graphs are highly efficient with connected data. So think of if you're continuously joining a lot of tables, graphs may be a better fit. They're very friendly towards data science. It's a very different paradigm from relational databases. The common query language is Cypher. And also, apparently this is my favorite phrase in this talk. I'm just realizing it's easy to understand, hard to master. You'll see that these queries are easy to read in the beginning, but they can get very complicated really quick. So why are graph databases good at what they do? So relational databases by themselves, you can represent them as every table looks like one of these silos, like one of these columns. Oh, I don't know why this moved. But there is no real connectivity. If you have connected rows, you're going to have to provide, you're going to have to run a join query. Whereas in a graph database, you're having constant lookup time because the physical relationship is laid out like this. It comes with other costs, but when it comes to having highly relational data, it really changes the way you can run things. For example, you can do variable length paths. So you can just be like, hey, I want to find the closest distance between two people. I want to find the closest distance between two places, recommendations, things like that. Graph databases are excellent for that. And so why would that be a good fit for an MCP server? There is really just one big word for that, and it's called knowledge graphs. I think if you want to implement graph databases in your organization, knowledge graphs is like the holy grail that you want to look at. This is basically the magical moment. It's like a subjective term, but it's best defined as this magical moment when everything is described, every piece of data that is relevant for your business is described in a semantically correct way. Like here is an example of this. You can just read how everything flows, right? An order contains products. The product has a type of snack, type of fruit, belongs to categories. Everything kind of reads in terms of verbs and nouns. Every node in your system is a noun. It's something that is, and it acts upon another noun using a verb or a relationship. And the semantic part really is the powerful part here because that's what LLMs are good at as well. So if you have like a good knowledge graph about your system, it enables a lot of things. And the easiest way to get all people started with this is by just hooking an MCP server on top of that, and you can unleash the power of an LLM on top of that. So, for example, if you have a good knowledge graph, it would enable non-technical users to ask deep domain questions, right? If you have a whole database of your production line, some manager could just come in and be like, what what is our most used tool in the factory, or who is my most successful salesperson. And it would be very easy for the LLM to figure out what queries to run. And basically the non-technical user doesn't even need to think about that. Then of course it's all about the semantics. They are related, and it makes the context retrieval very fast and meaningful because of the fact that you got constant lookup time between these nodes. It's also the graph databases are a NoSQL database, which means they have a flexible schema. So if you are prototyping, the ontology can continuously evolve. Then we have the fact that it also helps with the explicit reasoning. It's very easy to debug how it came to this query because it's going to put it in words and nouns, things like that. And like I said, it's very easy for rapid prototyping, and I think we're going to do that a little bit in our live demo on like a very basic knowledge graph of like how you could ask it to define a recommendation algorithm or something like that, or a popularity algorithm, things like that. Just so you know, the way Cypher looks like, nodes are connected using relationships, and the initial people that were designing the database were pretty nerdy. They loved ASCII, and so they really made it ASCII art. The whole Cypher language is based on the fact that nodes are in parentheses and relationships are in square brackets with a direction using an arrow. But yeah, and of course, if you want to develop it, you got to realize how to connect to it. For that, you have to use a driver. If you want to use a driver, you have to have some good understanding of networking, object-oriented programming. If you're doing it on like a production scale, you got to understand high availability concepts, and then some common database paradigms. But I really feel like, in the interest of time, I don't want to go too deeply into this. This is the part that I know the best. It's the part that's the easiest for me to keep talking about. But I think the real important thing that you need to know is when you are working with a driver, there's really 5 mechanisms that are at play. There is a driver itself, which you create and owns a connection pool. Then you have a session on which you run transactions. Transactions use statements, and they provide a result. So everything like wires back together pretty nicely. So yeah, the driver, I think the most important part about this is that it owns the connection pool. So what I've seen a lot is people creating 10 drivers in their application, and they've created 10 connection pools. It's not really an ideal situation. It's an ideal candidate for a singleton pattern. And here's an example of how you create a driver. It's just a URI and a configuration. So here is a typical one. This shouldn't be new if you've ever worked with PDO or something like that. You have a DSN. This is very similar. It's basically the same. So like I said, if you work with a driver, you probably want it to be a singleton. Not that it's enforced, but it is an ideal situation. And I think that's really the most important part when it comes to the key takeaway in this short section. Then we have the session. This is really the part where you are borrowing a connection, and this is where you're doing all the work on. So if you want to run any queries, you'll be doing that not on the driver itself, but on the session. So you can see how things wire together. From your driver, you can ask it to create a session, and you can ask it to be in a certain access mode, which if you're developing an MCP server, for example, you may want to have this access mode set to red at all times, which means that every write transaction will get rejected. No real damage can ever be done to the state of your database. So I think, whereas with the key takeaway of a session is contrary to a driver where you probably just want one of them, in a session you want to create them as much as possible. You only want to reuse a session if the work is related. And that really is important when you are working in high availability concepts, because there are some issues routing things, waiting on changes to propagate in a cluster. And in order to not have to worry about that, you want to reuse the same session. But for a simple setup, you don't really care. You create a session and you start running queries. And then, of course, there is a transaction. You should all be familiar with this. You begin a transaction, you roll back a transaction. But even when you are running a simple query, you're doing what is called a one-off transaction. So these are the atomic units of work. They contain one or more query. They're bound to a single connection. And once it's done, they give you something back called a bookmark, but that is only relevant in high availability situations, which is for a different talk. What is there to say? There are three different types. There's auto-committed, transaction functions, and unmanaged transactions. Auto-committed queries are the ones that you should be familiar with if you work with PDO as well. You just have your instance and you start running queries on it. Every run is its own transaction. Once it's run, it's done, it's permanent, it's in the database. You don't have to worry about it anymore. And then you have the concept of transaction functions, which I don't want to go too deeply in because this is very powerful only in like high availability concepts. But this is saying, hey, I want to run multiple transactions and I want to make sure that it retries in the form of a failure. So they look more like this. Did I add an example with multiple runs? No, I did not. But like the idea is that here you do more complicated things, or more complicated pieces of work. And if something fails, like if a node fails or if there has been a leader switch, the driver will rerun it for you. It's pretty powerful when you need it. And then this is the classic transaction where everybody thinks about. It's the unmanaged transaction. This is something that you begin, you run, and then you commit it or you roll it back. This should be very familiar to anyone. So yeah, I think when it comes to key takeaways, I think once you open up a transaction, it's bound to one connections. I've had this question a few times. You cannot nest transactions in on one another. One transaction is its own thing. It lives separately. When it's done, it's done. If you want to keep it simple, just start running on a session and it's auto-committed. If you want to be super secure about everything, cover all of your bases, using transaction functions are the preferred way. And then there is, of course, a statement. A statement is a cipher string and parameters, just like SQL. We are vulnerable to injections. You can resolve this using parameters, and it also helps with caching. And then there is the results. Results are coming back, even though it's a graph database, they will come back in the form of rows, and they can be consumed by iterating over it. Big part of it is that they are read once, usually. So once you've read it, it's done, it's a cursor. Here's an example of how you read it, of how you use it. You have your session, you run it, you get the results, you can do whatever you want. If you run it again, depending on how your driver is configured, you probably won't be able to run it again because it's been discovered. It's been read once. And then you have some useful metadata that is available to you. So here's a sample of all the metadata that you get back for every query that you run in the result set. So key takeaways, results are cursors. They are very useful metadata. They also important. A result keeps the connection open until they are consumed. Again, this is something that I've experienced a few times with people having too many connections open. It's basically sometimes because they just haven't looked at the results and closed them. Once you want to read the metadata and you want to read all of it, the result have to be fully consumed because it includes things such as when the data was last consumed. And also a key difference compared to PDO is that it will return like Neo4j specific objects. So if you return a node, you will get returned a node object. If you return a path, you will get returned a path object. So it won't just return basic primitives such as integers, strings, arrays, things like that. So yeah, if you want to use the driver and you want to be good at it, you got to understand the business blocks. You got to understand how to optimize the low-level configurations. And I think more than anything, you got to remember to have fun. I think sometimes that's forgotten, but it can be pretty fun to play around with new technologies every once in a while. And of course, you can debug and profile a lot of things using the driver as well. So this is it. I think this is the time to go into the demo, back to the MCP and how you would set all of that up. Of course, the demo is downloadable, and I just want to tell you the main things that I've been featuring here is the Neo4j bundle for Symfony that we are maintaining, and the Symfony SDK bundle, which of course Symfony is maintaining. And yeah, I just would love to get this started. I am open to get questions in the meantime, if anybody has some. Otherwise, I am just gonna start presenting my entire window, or my entire screen, I think is the easiest to do this. There you go. All right. So I am hoping that you guys are able to see this. I see my own screen, my own face in full, and I see in the back that my screen is being shared, but I don't see it in the chat. I don't know if that is, yeah, there we go. Okay, perfect. So let me turn on presentation mode. So I've been dealing now with I love PHP Storm. It's my go-to tool for all the programming that I do. But I do use Cursor to do all of the LLM generated stuff. So I just have both open. So we'll be switching a little bit between the two. But for the code overview, I think it's simple to get started here. This is a typical Symfony project. It should be familiar to the average PHP developer. Key configuration. The driver is set up in the simplest form. It's just going to use your environment variable, and it uses a DSN. If you want to see how that hooks into your system, let me do docker compose up. Let me set up everything as well. There you go. I can do this bash. So it's waiting for Neo4j to set up. There you go. So if I go bin console debug container and I grab Neo4j, you'll see that it's basically all the building blocks that I was talking about. The driver is here, the session is here, transaction is here, and then a part that I didn't talk about, the client is here, which is like an abstraction if you want to have multiple drivers. It's a bit of an over-engineering problem. This is something that is still there, but it's recommended to keep things simpler and stay with the driver. And like I said, the driver is supposed to be a singleton, so it'll be registered as a shareable service, whereas a session won't be a shareable service by default. Like, it's putting in some sensible defaults. It's putting in events that you can hook into, like when a result has been consumed, before it's been consumed. It had some performance profiling, things like that. So it's all set up here. And so there's a bunch of auto-roading. For example, I have like a ping command here that just has the session interface in here. And it's just giving you some information if you want to ping the Neo4j database to see if this works. So we can run this bin console, what was it called again? Neo4j ping. Let's see if the database is live. Yep, it works. And the Neo4j Community Edition is available. We do a very slow response time for some reason. Okay, I got to 10. I think it was a cold start. So yeah, and then the more important part, which is the MCP part. I think if you go take a look at the Docker Compose file, I think for the sake of educational purposes, I have added the official Neo4j MCP server, which handles a lot of the more complicated stuff. And then we have a naive Neo4j PHP MCP, which we have set up. So all of this is configured here in your Docker Compose file. There's a Neo4j database. So if you want to test this out, all you got to do is run Docker Compose up. But more importantly, if you want to see how to configure all of this, first off, there is the mcp.yaml file. So you can see I have Studio enabled, I have HTTP disabled. It is gonna add some basic details, and it's as far as I understand, it's configured to read your entire folder. I'd love to start adding some PRs of my own in this, but I think it's hard coded to only go. Don't quote me on this. To go through all of this and to go through all of your codes, but it will at this moment. And so I've made this Neo4j capabilities object. So these are the capabilities that I have defined. There is the run cipher query, which is added as an MCP tool. So it'll use this query, this reflection of this method to understand like what the arguments the tool need to function. And then it has an execute. And of course, this is the whole implementation of it. It's a detail. You can implement it your own way. Then to make my point as to why you may want to run your own quick server instead of like a predefined one is you may have something that is important to your system, for example, audit data quality. You could ask, for example, the AI to build something, mutate your database, whatever it is, but ensure that with every change, the data quality is maintained. These are just arbitrary numbers that I came up with. And then, of course, as a resource, I've added the schema. And so all of this really converts pretty nicely. So if you want to hook all of this in there, what you got to do is you got to add this in like an MCP file. This is specific for Cursor. So it's basically just going to say a list of MCP servers and how to run it, how to start the server. And it is smart enough to figure out the rest on its own. Case in point, let me open up Cursor. There you go. This is the same project. This is in Cursor. So if I go into the settings here, there is a tools and MCP section. And you can see that these two are on. And it looks like the demo gods are not working with me because it's red. It's supposed to be green. Let me turn these back on. OK, we just had to restart them. And so you can see that the whole system is smart enough. These are the ones provided by the official Neo4j one. It has a get schema, read cipher, write cipher. So these are design decisions. They made the get schema a tool. I'd argue it's better fit as a resource, but potato. And they make specific endpoints for reading and writing queries for protection, whereas we had a more naive approach where we just have a run cipher query and an audit quality. And you can also see how it like adds more data. It shows that this one doesn't have parameters, whereas this one has a query and a parameters one. And then it has a database schema. There you go, and it's giving some details about this. Actually, I've never clicked on this. Interesting. Anyway, so this is what they are, what they look like. So now let's just imagine you've hooked this in. Let's just first imagine we're like a non-technical person. First, to give you some more information about the data set itself. The data set is a classical movies data set. So if you want to inspect this, this is the database itself. You can do match X, return X. No changes, no records. There we go. Something had to go wrong with the data set. There was supposed to be a movie set in this. Let's see if there is a quick way for me to get this started. I think when I was running, I moved some things in here. Let me get that back. Okay. Quickly get that back. Git revision. I suspect that these may have been more important than I thought they were. Are they in here now? Okay, let's restart. Let's see if this changes anything. Okay, server has been restarted. Okay, so let me run the show file, see if that changes anything. Because this is actually the cool part, but we do need some data. Yep, there we go. It's been inserted. Let me run this again. Here we go. So we have a whole database filled with movies, people. To give you an idea of like why this is considered like a knowledge graph, if I do call db.schema.visualization, like even like a non-technical person could take a look at this. It's of course a very simple example, but this is a database that's going to tell you which person follows another person, which person acted in a movie, directed a movie, produced a movie, wrote a movie, or reviewed one. And so if you go take a look here, like I can just open up, for example, any of these nodes, and it's going to open up into other nodes. So it's saying, for example, Danny DeVito in this database has directed and acted in the movie Hoffa, and One Flew Over the Cuckoo's Nest is acted in. If I click this, it's going to show me the other directors, the other actors that are registered in this database. So you can see how this all kind of wires together. So the question then becomes, good, this is excellent, but how does MCP hook into this? Well, let's just say we have a naive chat box that we'll set up in here. It has to be on agent mode because it needs to be an agent to call these MCPs. And we're like using the, you can give it a nudge, you don't have to. MCP server, usually it's smart enough to pick it up. Using the MCP server, what can you tell me about the current database connected? There you go. Let's see. It's going to start yapping. All right, so it figured out that there is a get schema call in the MCP, so you can see that it called that first. Then it's starting to read some ciphers. So here it says like, okay, if I want to know more about this, maybe it's good for me to know how many nodes are in here. Maybe it's good for me to know how many relationships are there. And then it's going further and it comes back with an overview of the amount of nodes, the labels, which persons are in there, blah, blah, blah. And it says, okay, it recognizes it even as a classic Neo4j demo database, but let's make it a little bit more interesting. As you like, according to you, who is the most popular actor in this database? All right. And there it goes. It starts running more queries. And so here it's saying, okay, I think in this database, Tom Hanks is the most popular actor because he's acted in 12 movies as he's dominating like this. So yeah, this is pretty cool. But now let's just say like, okay, we want to start prototyping this. We want to prototype a popularity endpoint. So let's move on from this and be like, can you create me a small HTTP endpoint called get, for example, an endpoint get popularity that returns the top 5 most popular actors. Make it a proper popularity algorithm with ways I can later adjust myself. Okay, so it's gonna start figuring out what it's gonna do. Okay, this is a big problem with AI. Like, it tends to be overachieving, it tends to do a lot of things, but it's also a great way to just get started and start playing around. Looks like it created the controller and the service, so we can already start inspecting this. It's popularity service. Here you go. So it came up with a popularity service. Let's see if we are happy with this. So in this way, to determine a popularity, it is going to start looking which person acted, directed, whatever it is. Okay. So you can see here that it's weighing the popularity in here. Let's give it some pushback. All right, I just say, for example, let's keep the weights in the query itself. I think reviews are of the most important decision makers for. Let's see what it's coming up with now. Sometimes it takes some time. Popularity score breakdown. Okay. All right. Last time when I tested it, I was smart enough to add all of these queries in here because this is not going to be a good way to figure this out. Cipher query, not don't post process into PHP. And after that, whatever it comes up with, I feel like that's when we should call it a day. You guys shouldn't be here watching me have a discussion with an LLM. But I hope like this gives like a good idea of like how MCP can make it easy to connect to these things, how you can have more fine-grained control about everything, things like that. There you go. And it's finally figuring out the weights, but it's not smart enough to figure out that these should be parameter. Oh, it is. It is actually. There you go. It added all of these things. It adds it as parameters. And so now we have like a starting query to decide for us. Like, okay, what is the most what does it mean to be the most popular actor? And we can play around with the weights, play around. Like maybe we should look if we could dig more into like nth degree relationships, things like that. But yeah, it's just gonna keep doing its thing. But I think this is a great place to end the demonstration. Yeah, I think I am done with the full overview. And I'm just excited to hear feedback on this. If there isn't people, if you guys have been enjoying it, and if there are any questions.
Yeah, I'll check the chat here for some questions. I'll bring up Chris and Bobby are here as well, in case they might have anything. So as people are typing there, I actually have one for you, Glenn. So I know you've mostly been talking about how it can help in the application, like maybe with a chatbot to the end users or your business stakeholders asking questions there. But how well does it work for like a developer perspective? So, like example, if you have a new developer on the code base, can it ask it stuff like, "Hey, how do we store user preferences?"
So the specific use case you're talking about, there is a new developer, and you want the developer to be able to ask, like, how do I store user preferences? How MCP
or just asking it questions about how like the data is structured. Does it work well for that?
Yeah, I'd say I think as usual, like it's gonna depend how you implement your MCP server. I think the core thing that I have been seeing is, again, with like LLMs being so needy. There have been times where I've seen it, like when like a user asks that question in Cursor, for example, it'll at some point even result to running like direct PDO queries in the console, which is just unsafe. I think in the end, you want to be able to have more control about that. But if it's definitely going to help with people adding that question, but it's going to depend, of course, how well the user preferences are stored. If you're having like a very archaic system and user preferences is like written, I don't know, like if it's just like, for lack of a better word, like badly designed, like the semantics aren't lining up and the name is under column key 0 and you know what I mean? Like if these things happen, it's going to be useful. But if you have like a standard, easily digestible system, the LLM will definitely be able to pick that up, read your database schema, and just be able to very clearly state these are the parameters that are required. And here is an example piece of code that you can run to do it.
Interesting. Well, I'm not seeing any more questions, so I'll just go ahead and thank you for the presentation. I know I definitely learned a lot, and hopefully we'll get some good feedback for you. And if anyone's too nervous to ask a question in the chat here, Glenn's got his contact info on the screen there, so you can follow up with him. Logan's got a question here.
Oh, any benchmarks? No, I have no clue. PHP MCP is still so new. It's a great question. I think the biggest bottleneck is most likely going to be the reasoning aspect of the LLM as well as just how well you define context. Like the more context you give it, the longer it's going to have to think, the more expensive the queries are. And I think this is like the real aspect, the real time sink. I don't know if like at this aspect, like how much like the Studio protocol implementation in Python differs from PHP. I don't know how big of an effect that has, but it's a very interesting question. And it's definitely something that if nobody has done it, I'd love to just check out.
All right, last call for questions. All right, then. Well, thank you again, Glenn, for the presentation. And I just want to remind everyone that we're going to be back 2 weeks from now instead of our usual 4 weeks or 5 weeks from now. We're doing lightning talks. Please remember that if you have something that you want to share, I guarantee you there's someone else in our audience that does not know anything about that topic. So please submit your lightning talk, and we will see you in 2 weeks.
All right. Thank
Bye,
you,
everyone.
Bye.